Now, we're going to talk about solving equations involving indices. All right? So yesterday I've been through index law and then a few other things. We simplify some expressions. Now this time we're going to look at equations. So the equation we are looking at is unknown in the indices, and then we'll look at unknown in the base. All right. So let's think about how to solve it. The thing about with unknown in the base, you need to apply the fractional indices or radicals to obtain the power of 1 on the variable. I will talk a little bit more about it. This is probably the newest thing that we have not learned from last year. The rest, you probably have done it. Very quickly, just go back to the index notation. So the index or base is just the number here, the base, and then there's an exponent or the power of the index. All right? So n, b to the power of n, it just means n lots of b. That's all. Now, you've got this. I have, do you want a copy of this? No? Okay, if you don't need it, that's fine. It's all in the lesson slide. You can just print it if you want to, and then stick it on your book. If not, don't worry about it. Now, we're going to talk about something like this. Example like 2 to the power of x equals to 16. How would you do that? How would you solve for x?
You go to the 16.
Yes?
2 to the power of 4. X equals 4.
Are you sure 2 to the power of 4? Now, if you're not sure, all right, it took you a while to think about 2 to the power of 4. How about we write it down this way? First.
2 to the power of 2.
And then 2x equals to 2 to the power of 2 to the power of 2. So 2x equals to 2 to the power of 4, therefore x equals to 4. Basically, what you really want to do is equating the indices, that's all. Alright? You just need to equate that. That is what you're looking at, that's what you need to do. Alright? So the next one, 8 to the power of x equals to 4. How are we going to do it? Bring everything to 2. Power of 2. So you've got 2 to the power of 3. X equals to 2 to the power of 2. So therefore 2 to the power of 3x equals to 2 to the power of 2. 3x equals to 2. X therefore equals to 2 over 3. Pretty straightforward, right? Now, let's try this one. How are you going to do this? There are a couple of ways of doing it. I got to remind myself. So there are a few ways of doing it. First, number 1, you can just basically divide both sides by 3. 5x equals to 625. Yeah? And then you know that 625 is 25 square. Correct? 5x equals to 5 square. X therefore equals to 4. Right? Or you can let a equals to 5x. The power of x. So 3a equals to 1875. A therefore equals to 625. And 5 to the power of x equals to 625. And follow the steps. It really doesn't matter. If you can do it this way, if you can see straight away, do it. If not, you let a or any numerals equals to 5 to the power of x. Next one, again rearranging. 4 to the power of x equals to 59 plus 5, which is 64. So you know that 4 to the power of x equals to 64 is actually 8 times 8, 8 square, or 4 to the power of 3, correct? If you know. So you could let's do it as 8 square. So 2 to the power of 2x equals to 2 to the power of 6. 2x equals to 6, therefore x equals to 3. Now, sometimes if it is not obvious, it is actually a little bit more straightforward if you break it down to two same base. Yeah?
Yep.
Alright? Now, what about this? What is 343? Thank you. 343 is 7 to the power of 3. Or, yep, that's correct. So, therefore, you know that 7x equals to 1 over 7 to the power of 3. 7 to the power of x equals to 7 to the power of minus 3. Therefore, x equals to minus 3. What about the next one? Getting a bit more
Change it to
complicated. Thank you, 1 over 5. Change it to 5. So 5 squared to the power of 3x minus 1 equals to 1 over 5. So therefore, 6x minus 2 equals to minus 1. 6x equals to 1. X equals to 1 over 6. Alright? Pretty straightforward. All this as long as you know how to manipulate the power. Alright? Now, this is the interesting one.
7 squared minus 6, that's equal to plus or minus.
Which one? You must have plus or minus 6. Because minus 6 times minus 6 is 36. Correct? What about the next one? X cubed will be, x cubed is 216. What is x? Hang on, I don't want to show you that yet. Let me get rid of that. X therefore equals to 6. Now, what I really want you to notice, like what I told you yesterday, is this. If x to the power of n is equal to c, if n is odd, x will be either plus or minus. If x is plus, that has to be plus nth root of c. If x is minus, it will be minus nth root of c. Alright? Whereas if it is n is even. If x to the power of n is c, then x is plus or minus nth root of c. So write that down, please. That box is important. You need to know that. Whether it's odd or even. Odd, whatever power there is, whatever sign there is, that will follow. Plus, there will be plus. Minus, there will be minus. Alright? Whereas if it is even, you've got plus or minus. Think about even, you've got pairs. Pairs of positive or pairs of negative. Whereas for odd, you've got pairs of negative or positive, but you've got one odd one out, which is either negative or positive. Therefore, that's the case. Alright? That is quite an important concept. Alright, what about how would you do this? This is where you need to bring the power to 1. Alright? So, let me show you. X to the power of half equals to 9. Alright? So, if I want to bring the power to 1, I got to square x. Correct?
Yeah.
So, x to the power of half raised to the power of 2. Because 2 times half is 1. And therefore, this is 9 to the power of 2. So therefore, x equals to 81. That's how you do it. Make sure that everything is in the power of 1. So x to the power of minus 1. What I want to do is raise it to 1 times minus 1, correct? Minus 1 times minus 1 is 1. Is therefore 20 to the power of minus 1. And x therefore is 1 over 20. Yeah? So remember, if you've got x unknown to the power of something, what you need to do is bring the power of x to 1. Let's try this one, please, everyone. Try example 6a and b. I mean, A should be pretty straightforward, but B is the interesting one. Let you try it. All right. Now, same principle. What you need to do is rearrange until x is on one side. Right? So rearranging 6a. I have x to the power of half equals to 4 because 7 minus 3 is 4. Therefore, x to the power of half square is the same as 4 square, which is 16. Next one, use your idea of index law. What you've learned from index law. X is 1, square root of x is half. 1 minus half, x to the power of half equals to 7, square both sides, and therefore x equals to 49. Right? I think there's one or two more examples, that's all. Yep. The last one, how would you do that? I want you to think about it. I play around with 7a first, and then we'll go through 7b with you using your class pad. Try with 7. All right, 2 ways of doing it. You can use substitution method if you want to, which is substituting a equals to 7x plus 1. Or you can straight away just do it by squaring both sides. If you square both sides, 7x plus 1 equals to 8 times 8, 64, so therefore x equals to 9. Or, if you've got a long-winded one, you're not sure about that, do it this way. All right? Substitute. And finally, the last one, last example, grab your class pad and you can use your class pad to try to solve this. Just use solve. And by the way, when you use solve function, especially for trig, you've got to be so careful. A lot of you, when you solve trig function with solve, you were just taking the first answer, which is unfortunately not correct. All right. Ooh. So if you use your class pad to solve this, all right. 2x equals to 7. Class pad. Use your class pad. Go to main. Solve. 2 to the power of x. Oops. To the power of x equals to 7. And you got the answer. 2.80735. 2 decimal places, 2.81. All right? At least this is pretty straightforward. You don't actually have to think about 2 answers like in your trig. All right? I am actually going to stop here. And you have got plenty of exercises to do. And well, I made it 15 minutes.